In this video, we are going to see the second part of the modulus function. Just take a look at this graph. Are you wondering how this graph is formed? This graph is formed because of the linear combination of different modulus functions. You can see this modulus function combination y equals to mod of x minus 1 minus mod x plus mod of x plus 2 gives you this particular graph in red color. Let us understand how to draw this graph, or at least how to understand this graph and how to break this down into different intervals and draw the graph piecewise. The understanding of this kind of graphs is very much important if you are studying continuity and differentiability, especially differentiability. The first thing we have to observe is those individual modulus functions are becoming zeros at which points. In the first modulus function, x minus 1 will become 0 at x equal to 1, and in the second modulus function, x will become 0 at x equal to 0 obviously. In the third modulus function, the x plus 2 will become 0 when x is equal to minus 2. So let us draw these points on the number line. The behavior of these modulus functions can be clearly understood before and after the points where they are becoming zeros. So the first modulus function mod x, let us see, it is plus x when x is greater than 0, it is minus x when x is less than 0. And the second one, it is equal to plus of x minus 1 when x is greater than 1, and it is minus of x minus 1 when x is less than 1. In the same way, mod of x plus 2 equals to plus of x plus 2 when x is greater than minus 2, and it is equal to minus of x plus 2 when x is less than minus 2. The reason behind taking these modulus functions this way was already explained in the part 1. I am giving the link in the I button, please take a look at it. Here on the number line you can see there are 4 intervals formed: minus infinity to minus 2, minus 2 to 0, 0 to 1 and 1 to infinity. Let's understand how each of these modulus function behaves in these intervals. Let us take the first interval minus infinity to minus 2. Here x is less than 0, x is less than 1 and x is less than minus 2 also. That means these 3 conditions will be selected. So in the interval minus infinity to minus 2, mod of x minus 1 is taken as minus of x minus 1, mod x is taken as minus x, and mod of x plus 2 is taken as minus of x plus 2. So if we simplify, in the interval minus infinity to minus 2, we are going to get the function as minus x minus 1. So this entire combination of modulus functions in the interval minus infinity to minus 2 behaves as the graph, actually the line graph, minus x minus 1. In the very same way, let's analyze the behavior of all these modulus functions in the second interval, minus 2 to 0. We know that x is less than 0, x is less than 1 and x is greater than minus 2 in this interval. The function's behavior is as shown. So for the interval minus 2 to 0, mod of x minus 1 is minus of x minus 1, mod x is minus x, and this mod of x plus 2 behaves as plus x plus 2. After simplification, we will be getting the function as x plus 3. So in the interval minus 2 comma 0, the given combination of these modulus function behaves as y equals to x plus 3. In the same way, let us see how these modulus functions are behaving in the interval 0 to 1. In the interval 0 to 1, x is greater than 0, x is less than 1 and x is greater than minus 2, and hence these conditions are selected, and thus the function obtained in the interval 0 to 1 as 3 minus x. In the same way, let's say in the final interval 1 to infinity, here in this interval x is greater than 0, x is greater than 1 and x is greater than minus 2, which means all the modulus functions will be positives only in this interval. So we get the given combination of the modulus functions as y equals to x plus 1. And now you can see how this modulus function is behaving in these 4 intervals. And also this linear combination of the modulus functions is represented as a piecewise function as shown in the green color. This is why the graph is broken like this. From minus infinity to minus 2, the graph is minus x minus 1. From minus 2 to 0, the graph is x plus 3. From 0 to 1, the graph is 3 minus x. And from 1 to infinity, the graph is x plus 1. I am giving you a similar problem for your exercise. In the next video, we are going to see the behavior of a quadratic graph when modulus functions are applied.